Okay, so we have the first person on the presentation. Okay, so Kevin Krasinski will be presenting his poster. He will have 2 minutes to present. We have judges here. And okay, we have his poster. Okay, 2 minutes.
Okay, well, hello everyone, my name is Kevin, and I research avian influenza viruses. So, in case you missed it, my name is Kevin. I research avian influenza viruses. These viruses are spread locally inside wild birds, and occasionally they cause really costly outbreaks in poultry flocks or deadly bird flu infections in humans. So consequently, surveillance of flu viruses in wild birds is a priority for agriculture and public health officials worldwide. Now, typically, this surveillance involves testing captured birds for influenza, but it almost never detects dangerous strains before they cause outbreaks, so it's not a very effective surveillance tool. Now, my poster here is showing you a new surveillance method that we developed at the BC Center for Disease Control. Basically, our method recovers viral genomes from mud collected at wild bird habitats. So for this poster, I applied our method to 4 specimens that were collected across the lower mainland and Fraser Valley. And from the sediment specimens, I recovered 19 distinct flu genome segments from 11 different subtypes of the virus. And over half of these were at least 85% complete. So what was really exciting about these sequences was that when we did a phylogenetic analysis, exactly as we would hope and expect to see, they ended up being very similar to viruses that had previously been isolated from wild birds in North America, especially the Pacific Northwest, in recent years. So from this work, we've concluded that our whole scheme of sequencing mud for flu viruses has actually demonstrated the potential to be a viable tool for doing avian flu surveillance in wild birds. Thanks a lot.
Hey everyone, I'm Jasper from Martin vs. Hub, and I study epigenetics in leukemia. Yeah, it's very small. But anyway, so if you imagine your genome to be the book of bases that describe your being, then the epigenome is a collection of bookmarks that tell you what pages to read and to not read. So in certain acute myeloid leukemias, the mechanism by which these bookmarks are removed is disrupted, and certain pathways that dictate differentiation is then shut off. Now, these proteins that are in charge of this whole mechanism are TET2 and TET3. Now, because these are mere bookmarks in your genome, you can then imagine that if you're able to reactivate the TETs to remove these bookmarks, then you can reverse this leukemic phenotype and reopen up pathways to differentiation. Now, in this case, that's been shown by us and by others, that vitamin C is the most effective inducer of the TETs, and that you can induce this differentiation phenotype in both mouse and cell models. Now, I try to tease apart what effects are driven by TET2 and what effects are potentially driven by TET3. Now, to this, I use CRISPR to knock out TET2 and subsequently screen the collective changes of these bookmarks across the genome after vitamin C treatment. Now, from all this, I saw that regardless of TET2, if you add vitamin C to the model, the bookmarks that are nearby genes related to differentiation are reactivated and being lost. Now, I then went on to create more CRISPR models of TET2, TET3, and both. And I saw that phenotypically in my cell model, that as long as you have one TET present, you can then inhibit leukemic growth and induce differentiation through a long vitamin C treatment. That's it.
Hi, my name is Amanda, and I will discuss my project on utilizing proteogenomics to improve treatment selection for childhood cancers. Traditional treatments for childhood cancers are usually very aggressive, especially for young, growing bodies. So there have been a lot of innovations over the past decade or two that aim at mitigating these harsh effects. And a lot of those treatments are aimed at targeting specific genetic mutations. And for example, if there's a patient that has a mutation in a gene that codes for a kinase, that is known to cause overactivation of that kinase, the patient will then be treated with a kinase inhibitor. So the actual drugs are targeting the final protein, but the decisions are being made based on the genomic information. So what we really want to do is to combine the genome level information we get from sequencing with protein level information to understand how these genes are actually affecting the proteins, and that will determine how well they respond to the drugs that are targeting the proteins. So just to give an example, we've seen a loss of the CDKN2A gene, which is a well-known tumor suppressor in many of our patients. And when we see a total loss of the gene, we also see a total loss of protein. But in some cases where there's a one copy loss of the gene, we'll see total loss of the CDKN2A protein. But sometimes when there's one copy loss, we'll see normal levels of the protein. And this is actually an actionable mutation. So the patients that have this one copy loss on the genome level may be sent or may be decided to be treated with a drug that will target this pathway, but if they have normal levels of the protein, then they probably won't respond well to this treatment. So these are the types of questions that we're trying to address with our approach.
The three of you were absolutely amazing. And well, first, congratulations for making it to the three last ones from 22 posters. So, the great prize you will get is that you will get, well, you will get a check from us. So you will get some money, but you will also be invited to present your research a little bit more in detail to JLBC and all the stuff. So we'll coordinate that with you. So position number 1, we'll start with the winner. So we'll start with Kevin. We're almost coordinated. Okay, wonderful. Thank you. Okay, number 2 goes to Jasper.
Okay, you're good. Thank you.
Congratulations. And Amanda, great job. Okay, so to close the event, I want to invite Pascal, our CEO, to give the last very wise words for today.
Thank you, Catalina. And I have 2 mandates. 1, I have to get you out of here at 4:20. So I won't do this in any length. But what I really wanted to do is to thank Catalina for a fabulous program put together by her and her team. So a great round of applause for you. This is a team sport, and the CSO, Catalina CSO team, was ably supported by Sally's Communications, Education, and Genomics and Society team, so thank you very much. And then there were the many other helpers at registration, etc., who made that possible today. And so for all those who left, by the way, we'll do the poster competition next year before we do the last panel. Tell all the others they should all come back next year, and please come back next year for our Genomics Forum 2020, which I'm sure will be an exciting subject, as is cannabis. Have a wonderful evening, and it is not 4:20 yet.